Hello, my name is Mackenzie, and this is the presentation portion for the final project for database systems, and this is the Bright Horizons Kindergarten Management Database. So, this database was created and designed to organize and manage the information for just a small kindergarten school. This system is used for keeping the students, guardians, class, attendance, health, and tuition information all in one database, so it's easier to track and manage and to have one system instead of doing any of this manually, which causes errors, mistakes, and you could lose information that way. So this is just a much better way to track that information. And also it creates a more efficient, accurate, and reliable way for just the staff to look at details. They can monitor attendance. They can manage classrooms if there needs to be teacher changes, student changes, or even if the size is too large. It helps to maintain an up-to-date record of the tuition payments and health information for all the students, which is really important. The goals of this database are to just have one platform, as mentioned, for the attendance tracking, for patterns and potential reports that are needed, to manage tuition payments, to reduce errors with billing, and making sure that payments are made. Some other goals include the student's health and allergy information for quick access and in case of emergencies. This database, one of the main goals as well, is to support the staff and the organization of the school by relating teachers and admin to students, guardians to students, and information to students as well. So it all works together to create one impactful relational database. And then also, since this is a new database for this kindergarten, it would improve the accuracy and consistency of all the information that they have. So here's an example of the ER diagram I made. Most of these foreign keys go back to student ID. A few go back to the guardian ID. I used 7 tables here. So there's guardian, student, tuition, attendance, health records, class, and staff member. And you can see those fields that are included for each of those. So guardians is pretty simple: name information, phone number, and email. The students have name information, date of birth, gender, their guardian ID, and to connect to a guardian and their information, and a class ID so we know which class that they're in. Those are the 2 foreign keys for that table. For tuition, it has quite a few fields because there's a lot to keep up with here. So I did one for plan type because you can have different types of plans. You can have different monthly rates, so that's another field. Amount due, amount paid, your tuition status, the due date, and the student ID where this tuition relates to. So these all just keep track of if the payments have been made on time, if there's still an outstanding balance, and the type of plan, so we know some people may come for the full week and some kids may only come 1 or 2 days a week. So the different plan type is important, so then it knows what the monthly rate is. The class table has the class ID as its primary key. All have a primary key and pretty much just use the first or second word to describe what that ID is. And in my database, you'll see the first 2 letters. Like if it was for guardian, I believe it's GU and then underscore, and it starts with 001. So if it was attendance, it's like AT underscore 001 for those primary keys. So then when you're looking at a primary key, you can know what it is instead of just using random numbers. So back to class ID. So you have class name, the classroom, the class size, and the staff ID. The staff ID number is the teacher who is over that class. So class names, we have for classroom, we have rooms 1 through 6, And then for class size, I think I maxed at 20 students per class or 15. So somewhere around there. And then class name is a color. So it's red, blue, purple, and green. For staff member, we have their first and last name, their role, because you can have teachers, administration, nurse, security. So I added that in there. The staff member's email, phone number, and status. So if they're in the building, they could be marked as busy, they could be in a meeting, or they could be out of office or out of the building. The attendance table has attendance date, attendance status, check-in time, check-out time, and the student ID to, again, relate back to the student. All these are important for keeping track of attendance, and the attendance status would show present, absent, or tardy. And then health records, try to keep this one short, but this one has the record type, the record date and time, and the health record description. So the record type would be if it's an immunization record, an allergy, so an accident that happened on the school grounds, or medications. And then the record date and time just includes like when this was entered into the system, and then the short description, just what it is. So that's all the tables here. Like I said, most of these relate back to the student ID because it's about the students. But yes, I'll move to the next. So the next 10 slides are about the queries. So there's 10 SQL queries that were executed in the Bright Horizons database. And then it'll have the SQL statement and the output in the screenshot or snippet, and then it'll have a brief description of what the statement is doing. So for simple query 1, this query lists students from the classes CL_001 and CL_002, and it orders them by class and then by last and first name. So as you can see here, this is the query, and then this is the output. And as you can also see, I did use Bright Horizons database just to make sure I'm in the right one. So the output for this was just these 2 students. The second simple query is showing where pre-K blue classes are and orders them by their classroom number. So it goes from least to greatest classroom number. We can see the class size, the name is pre-K blue, and then the class ID for each classroom. So that's here in this query as well. The first medium difficult query, this query filters students using 2 conditions, class and gender, and then it groups them by class and it counts how many female students are in each class. So the class I chose was CL_001, 002, and 003, and there's only 1 female student in those 3 classes with all of these filters, and that is in class 002. For medium difficult, this query shows all paid tuition plans and how much was due and paid for each one. So this is the query again, and then here's the results. The first subquery, this query finds all students who have at least 1 health record and marks it that's marked as an allergy. So it just gave the student's ID number and their name. The second subquery compares each pre-K blue class to the average size of all the pre-K blue classes using the where clause. So I did, in this query, I selected the average class size because that was one of the fields I had under the class table. And so it could take that average and then give us this result down here. The next query is for inner join. This query joins the student and guardian on their matching guardian ID. to show the selected students with their guardian's name. And then here's the result down here. And this is the query above. This is where I had to use the S dot first name for the foreign keys. And the G dot guardian is also there. Next one is the left join example. This query uses the left join so that all selected classes appear even if a teacher record is missing. So it joins class to staff member on staff ID, which was the foreign key on that table. This is the view query. This view shows each student along with their class name and their room number. It stores an inner join so you can reuse this table for future queries. And I believe lastly, this query combines, this is the union query, it combines selected students and staff into one list using a union. Both select statements return the same columns and the union merges them into one. So lastly, these are some difficulties or challenges that I encountered while doing this project. First and foremost, ensuring the foreign key relationships were set up correctly across the related tables. So when I was adding foreign keys to tables, I wanted to make sure that they made sense. So a student can have one guardian, but a guardian can have multiple students. So I wanted to make sure I was doing that correctly. I was running into some issues with the queries and just creating them. So I had to fix those errors and troubleshoot until I got a result that would make sense. And that occurred both during the table creation and the query writing, just in different ways. I wanted to make sure that the queries I was making were simple and clear and easy to understand, so that I'm asking the question first and then writing the query. I wanted to make sure I was making the project as simple as possible just to show what I've learned, but still meeting all the technical requirements for each phase, especially phase 2. It was extremely technical. And then lastly, and I think this one was most important, was making sure the relationships had realistic examples in the data. So when I was creating the guardians, I had to make sure they related to multiple students, since that was one of the relationships. And then there were 2 teachers that had 3 classes each. So I wanted to make sure that was in there too to represent those relationships. That is the end of my project presentation for the Kindergarten Management Database. Thanks for watching.